I'm Tom.
My name is Fiona.
And I'm Fiona too.
And welcome to
The Couch Potato Lab.
This is the show that brings the science right to your home from the comfort of your couch. It's sure to cause a storm in your household. You might not know it, but that was a joke. So let's just get into it. Let's start to the left of me. Who do we got here?
Hello, my name is not Fiona, but it's Kobe. Thank you. Hello. My pronouns are he and him, and a fun fact about me is that my middle name is a body of water. Yeah, so we're going to talk a lot about water and phase changes, and yeah, can you guess what my middle name is?
Well, you just said it, Kobe. It's a body of water.
Oh.
Hi, everyone.
Right.
I'm Tom. I will be your host for today. My pronouns are he, him. And a fun fact about me is that I could only skateboard backwards. That's right. I try to go forwards. It doesn't happen. It's a physics miracle that I am still able to skateboard to this day. Thank you. Who do I have to the right of me?
Hi, I'm Fiona. My preferred pronouns are she, her. And a fun fact about me is that I greatly dislike wearing slippers with no socks. So I always have to have socks when I wear slippers.
So like socks and sandals, is that a thing that you like?
Yes, I wear socks and sandals a lot, actually. My mom makes fun of me.
Well, I'm in the party of wearing socks and sandals because you know what? You can never be too safe out there. Yeah.
All right, and for today's episode, we would like to begin by recognizing that we are having this live stream and we're operating as eyes on Treaty 4 land, which is the traditional territory of the Nehewak, Nukaway, Dakota, Nakota, and Lakota peoples, and the traditional homeland of the Métis Michif Nation. So we're so grateful to be able to share this land with these peoples and to recognize that you, the viewers, may be coming from different various numbered treaties or unceded territory. So thank you for taking the time to recognize this with us and joining with us here today. Yeah.
Thank you very much, Kobe. Let's get today's episode started. And I think there's nothing more exciting to start off an episode about the weather and bodies of water and all that wonderful stuff than a weather report. So if you'll follow me right here, I have today's forecast. Yeah, we could pick that up pretty good. I'm just going to move that. Oh, yeah, that's money. As you can see, today's forecast is 16 degrees Celsius. It's a little cloudy, a little sunny. Thanks, Kobe. As you can see there, the sun is just peeking out behind that cloud. So it's not quite beach weather, not quite,
Guess we can't camp.
And you know what? We have a 40% chance of rain.
Oh, that's even worse.
Now, I went to weather person school for 40 years, but I still don't know what weather is all about. Can any of my experts help me out here?
Yes, to understand about the weather and clouds and all that cool stuff, we need to learn about phase changes. And in a few episodes ago on Crystal Paint, we learned about the 3 states of matter. So that would be solid, liquid, and gas. But what phase changes is the reaction that changes one state to another state. So for example, a process that changes liquid to solid or solid to gas and gas to solid there's so many phase changes and reactions that we're going to review and talk about them today. And I see that Fiona over there is doing something really cool. I see maybe it's like vaporization or something. Yeah.
Yeah, Kobe. So I have a pot of boiling water here. And what phase change that is, it's called vaporization, as Kobe mentioned. So what it's doing is it's turning liquid into gas. So when you boil water, it has all those little bubbles that you see, and that's actually the gas trying to escape the water. So yeah, and that's why if you boil water a long time too, you're going to end up with no liquid water because it all gets turned into gas.
So it's like the liquid reaches like a boiling point or something. So like I know that water's boiling point is 100 degrees Celsius. So once it reaches that, then it turns into vapor. But I think what's really, really cool and another really cool phase change is chocolate making, right, Fiona? Chocolate making is the next phase change.
Yeah, so inside my boiling water, I have started to melt some chocolate. So here, I'll take it out now. There we go. So I have turned solid chocolate bars into liquid chocolate. That's pretty crazy. And that is the process of melting. So you can see it's very liquidy and it's not a solid chocolate bar anymore. And yeah, I did that by adding heat to a solid and that made it melt. So that would be the melting point. But I have to say, I don't really enjoy eating just plain melted chocolate. Covey, do you have something that I could maybe put my chocolate on?
Yes, Fiona, of course I do. So Tom's favorite thing in the world is ice cream, and I have a pint of ice cream right here just for him, but he loves the extra chocolate. So since we're going to use that melted chocolate that Fiona made, we're going to put it on our frozen ice cream. But the thing is, ice cream is also demonstrates a phase change as well. So ice cream, what happens is that the cream freezes and makes ice crystals that forms ice, or it makes the ice in ice cream. So that's what you get right here, which is this delicious treat. And I probably would love that chocolate over there, but we're gonna probably toss that melted chocolate on this pint of ice cream later on. For Tom to enjoy.
Well, thank you so much. I'm already feeling my brain bursting with new knowledge of phase changes and all that. So if I were to use water as an example, so we have rain, we have snow, but we also have ice. I know particularly in the winter. So would ice melting in the spring because it's getting warmer, is that an example of melting, or what is that?
Yeah, that is an example of melting, Tom. So when our Earth turns, it changes seasons, and the Earth gets a little warmer, and that causes the snow and the ice to melt, and that's a phase change of water.
Well, you heard it here first, folks. That is exactly how it works. Thanks so much, Fiona.
And in order to get ready for this activity, there are a few supplies that you will need for this episode. So we're going to make clouds in a jar.
What?
How is that going to work?
How does that work?
It's going to be really, really cool, and we're going to deal with another phase change that we're going to talk about later on. So what you're going to need is maybe a jar. Today we're going to use a beaker because science. But another thing that vital importance, another important supply you'll need is hairspray. You're going to need water, of course. You're going to need to boil that water, and you're going to need a bag of ice.
Ooh.
Yes.
Ice cold.
All right, so Fiona is the expert of making clouds form. So Fiona, what is the next step? What's the first step to making some clouds?
All right, so first we're going to take our lovely jar or beaker in our case, and we're going to take some boiling water, and we're going to fill it up about halfway in our beaker. So I'm going to take my previously boiled water, and I'm going to hopefully dump some in here without making too much of a mess. I made a mess.
And again, folks at home, if you're having a bit of trouble pouring hot water, make sure to use a parent or guardian's assistance, because hot water is hot. It's in the name, it's dangerous, and we don't want you spilling it anywhere. So please be careful. Use a funnel if you can, or a good old-fashioned parent or guardian. Thank you. Back to you, Fiona.
All right. Yes, that's an awesome point, Tom. Safety always comes first in science. But now that we have half a cup of some hot water here, what you're going to do is you're going to want to add some hairspray to the top. So you don't need too much, just kind of a couple spritz, just so the top has some nice hairspray coverage. So, and Covey will show the next step after that as well.
All right, you're going to need to be extra fast, right? Your reaction time is super important. So once you spray that hairspray into your jar of hot water, you're going to slam that bag of ice right on top and covering all the sides, right? We want to make sure that this jar is a closed system so that no elements or chemicals or vapors are escaping. All right, on your marks, get set. Spray and close. Ooh, it smells very nice.
All right, what do we see here, Covey?
All right, as you can see, there are some vapors from the hairspray inside. So what's happening here is that there's a boiling water, so that's one of the phase change, evaporation. And then we got our vapor of hairspray, and what's going to happen is that this hot vapor is going to contact that bag of ice, and then a new phase change is going to happen, and that's condensation. And Fiona is the expert of condensation. Fiona, take it away.
Yeah, so condensation is really in our everyday lives. So it's how clouds are made, actually, Covey. So the way that condensation works is, I'll use clouds as my example. Water from the earth rises into the sky as vapor and gases, and then up in the sky is actually colder than it is on the surface of the earth. So as it goes up in the sky, it starts to form tiny little water droplets, and they all join together, and water likes to stick to each other, so that's why we get clouds out of it. And our clouds, then once they get so heavy and the water droplets can't stick together anymore, it starts to rain, and that's why we get rain as well from our clouds.
Oh, so it rains because the clouds are heavy with water.
That is right.
All right.
Yeah. All right. So, right now it's very faintly, but I can see that my vapors from the hairspray is like circling, and there's water dripping as well. So that active like circulation signals that there's water droplets, that the air molecules of the hairspray is catching those water droplets right there.
That's very,
very faintly.
That's very cool. And I think we have our first question of the day that has to do with phase changes over here. What is the difference between vaporization and evaporation? Do either of you know this question?
Yes.
Yeah? All right.
Yeah, I'll take it.
Yeah, you got it,
so evaporation is a type of vaporization. The other one would be boiling. Yeah, so that's what the difference between evaporation and vaporization is.
Okay, well, thank you so much. So we talked about clouds. We talked about why it rains. But, I've always wondered this when I'm, boiling a kettle, making a cup of tea, as we do in the afternoon here. And I wonder, where does all that water go? Where does all that vapor that's in the atmosphere, where does it go? Is it gone forever, or is it just, what's happening to it? Covey, do you know?
Yes. So a couple episodes back, we talked about conversating about conservation, and things never are destroyed or or never destroyed or never created. So whatever happens in the water, if it vaporizes, it turns into air and is part of the atmosphere. So eventually that's going to condense in clouds, form clouds, and then it's going to rain. So it's a huge cycle. So water is like being reused over and over and over again. Yeah.
Very cool. So it's kind of like recycling in a way.
Yeah, it's like recycling. And another name, a scientific term that we can use is reversible changes. And that's what water is doing right now. So the thing is, we can change water from solid to liquid, and then we can change it back from liquid to solid. So that's what reversible reactions are, and water is a great example for that. But really, really cool, the opposite of reversible is irreversible, and I think that one's the best one. Why? Because we can make an egg, and making an egg or cooking an egg is an irreversible reaction. Yeah, so let's take a look. If I cracked an egg, Tom, what would the insides look like?
Well, the insides, and I've seen a few eggs in my day, would be goopy and yellow.
Goopy and yellow.
Goopy and yellow is my final answer, Covey.
Goopy and yellow. And how about you, Fiona, the expert of eggs and lover of eggs?
I guess it would be, I think it'd be like liquidy. Liquidy with a solid mass in the middle. That's what your egg is going to look like.
Yes.
Yeah.
All right, I'm going to crack this egg and then put this in the beaker so we can take a look at the raw egg. Ooh.
Good pour.
Thank you, thank you. Ooh, I should have done it with one hand. Show off my chef skills. Anyways, yeah, so you can see that the egg white, it's not really white, but it's translucent. And then the yolk, on the other hand, is nice golden yellow. Fun fact about eggs is that vitamin D is there's a lot of that in the egg yolk. So if you're lacking vitamin D or you're not going outside a lot, eat some eggs. All right, so irreversible reactions. Whenever I cook this egg, it can't go back to its original state. So I'm going to cook an egg for Fiona because since she loves eggs so much, this will be a perfect present for her. So Fiona, how do you like your eggs?
I guess if I had to pick one, sunny side up. But you know, Covey, I don't like eggs. We discussed this already.
Okay, well, I think we have a little showdown later. So if you lose, Fiona, you're going to eat this egg.
Oh boy.
Oh yeah. All right, I'm gonna cook this egg now. Wow, so fast. So what's happening right now is that it's turning white.
Oh yeah.
Ooh.
Wow.
So what's happening there is it magically becoming white, or is there some sort of biochemical process that's going on there, Covey?
All right, so the biochemical process is that the egg whites are full of proteins, hey? So when heat is added to those proteins, they can no longer change back, and the proteins change shape.
Oh, very
Yeah,
cool.
so unfortunately, oh, wow, well, looking good, hey?
I can't believe you're gonna eat that later on live TV.
Yeah, I totally
nonetheless.
forgot the oil, so it's stuck to the pan. Yeah, well, maybe you can, I'll scrap out the egg whites for you, Fiona. It's gonna be great.
Oh,
So yeah,
I can't
so
wait.
what's happening is that the proteins are being changed, so we're cooking the eggs. The translucent egg whites are becoming a more white of a color, and we can't change it back to its nice, yolky, translucent form again. Yeah, so that's irreversible and reversible changes.
So so we talked about how temperature, such like a higher temperature, can cause this protein denaturing. Yeah, let's keep the camera on Covey and that wonderful mess that he's making. So heat can denature proteins and make this reaction irreversible. So you might think that, what if I turn down the temperature? Would that turn it back into a goopy egg? And the answer is no, unfortunately. It's kind of like you broke it, you bought it kind of thing, you know? You turned up the heat, it's no longer going to be goop, is what I always say. Right?
Oh.
Right.
Right.
Yeah.
Fiona, so you're not getting a sunny side up egg anymore. You're going to get scrambled eggs.
Oh, it's
My
perfect.
favorite.
Just
Yeah,
like Sunday brunch.
Yeah, we'll top it off with ketchup. Maybe evaporate that ketchup by adding heat as well.
Ooh.
Let me
Ketchup
tell you,
vapors.
folks, at home, that the studio right now, you know, it's kind of like I'm getting a stereo of smells. In my right nostril, I got the smell of chocolate over there, but in my left nostril, I have the smell of eggs. And let me tell you, chocolate eggs, I mean, they're a thing, but real chocolate eggs should never exist. It smells great in here. We have a question here from none other than the Hayes brothers. They asked, what is it called when a gas turns into a liquid? Fiona, do you know?
When a gas turns into a liquid, that is called. Oh, I'm having a brain fart.
Gas
oh boy.
into liquid.
I'll tell you. I'll tell you.
Wait, I know this.
I know a brain fart
I got
happens
it.
to everyone. You got it, Fiona?
I
You
got it.
All right, Fiona's got it.
Okay, gas into a liquid is condensation.
Absolutely, condensation.
That's how clouds are formed.
Hayes
Yes.
brothers, we hope we cleared that up and maybe taught you a new term, brain fart. Use it sparingly. All right, how's that egg coming, Cove?
I've decided to put it in the beaker. I'm going to try to clean up this pan because we're going to move on to our next activity very soon, and I'm going to need this pan. Yeah.
All right, very
You have
good.
Another question?
Yeah, we have another question here. Penelope, this comes from Penelope. She says, I'm stumped. What's your middle name, Covey?
Okay, I'll give you a hint. Remember, it's a body of water, but not body of water. Maybe you might go swimming in it. Maybe you have a cabin near it.
Is it Ravine?
Ravine? Oh, you're so close. I'm gonna give you a chance, Penelope, to guess what my middle name is. One more time. Yeah.
All right, we might reveal his middle name by the end of the episode. Excellent. You know, we have a question here from Eli as well, and they want to know, how do you make dry ice? Well, yeah, obviously you can see that we have a cooler full of dry ice down there. Maybe you watched the live video beforehand, but yes, we do have dry ice, our good friend in the studio today. So dry ice is actually, it's not water. It's carbon dioxide, CO2. Maybe you've heard of it. We breathe it out, but in this case, it's actually super cooled and condensed so that it looks like ice cubes. And something really cool happens, but basically, it's really cold. Its sublimation point is about negative 78.5 degrees Celsius, so that's colder than any day in Saskatchewan that we've ever had. So something really cool happens when it's added to a warmer temperature, such as a beaker of water. That's a little soft spoiler alert for what's coming up next, but you know, we'll leave it at that. It is solid carbon dioxide that is super cooled. How are we doing, Covey?
Super cold. I'm ready. Are you
All
ready?
right.
Yes. I see that there are some guesses from other people. One of the guesses is pool. Covey, pool. I love that, but not quite right. But Tom, I am ready for the next activity.
All right, let's get on to it.
Okay, so the next activity is we're going to make some salt crystals. And the materials that you will need for this are 2 cups. You're going to need some salt. You're going to need a measuring cup and a measuring spoon. So what I'm going to use is 1 teaspoon and then 1 cup. And you're going to need a pot or a pan and a hot plate or stove because you're going to be boiling some water today.
Oh.
Yeah. All right, so for this procedure, Fiona will introduce the first step of this cool activity.
All right. So we're going to start out by filling up both our cups with 1 cup with hot water, sorry. And you're going to want to fill it up. Is it 1 cup of water, Covey?
Yeah, 1 cup of water.
Okay, 1 cup of water you're going to put in. And I have my previously made hot water that I used before, so I'm going to put this water into a new cup.
And I think hot water, or like warm water, is probably best because it helps the salt dissolve a little bit faster. Yeah, so. Yeah. Cool.
All right. So our goal of this activity is to make a saturated mixture. And what that means is that all of the solids in the mixture are able to dissolve in your liquid. So we're going to be using salt in this example, and we're going to add salt 1 teaspoon at a time, just so that we don't accidentally add too much and then it doesn't dissolve. And it looks like Covey over here has started to do that.
Yes, I'm adding salt. Remember, you want to do it really slowly because we don't want to make a super saturated solution. And what super saturated means is that there's too much salt that it can't dissolve into the water. So you're going to have some like leftover crystals later on. But ideally, what we're going to do is make a saturated solution and a super saturated solution. So I'm just going to, so far I'm at 1 teaspoon of salt. Hopefully it's saturated. You will know when it's super saturated if it has some salt crystals left. No matter how much you stir, there's just going to be those salt crystals still present. Yeah.
All right.
How's that coming along, Fiona?
So far I have put 2 teaspoons in, and it is dissolving completely so far. So I just added a 3rd one now, and let's see if that is too much. You know what? I think I might be just reaching the point because I can see close at the bottom that there are some salt chunks. I'm going to maybe add half a teaspoon next because it took longer for it to dissolve that time than it did the first 2. So I'm going to add less now just so I don't accidentally make it super saturated.
All right. We have a question here. It's a great question. So why does the salt dissolve faster in warm water than it does in cold water? Does anyone want to take this question?
I actually know the answer to that
Hey,
one,
you
Tom.
got it, Fiona.
The reason why salt dissolves faster in the hot water than the cold water is because heat tends to kind of break stuff down faster, and it makes stuff move around more. So the more that chemicals move around, the faster that they change. So
Yeah, that makes sense to me. The hotter the water, the faster you dissolve, right?
Yeah. And I
right.
have a little tip about if you accidentally made a super saturated solution and you still want to make and you're still working on your saturated solution, what you can do is just add a little bit more water, see if those salt crystals dissolve, and if they do, perfect. And maybe just add a pinch more of salt, see if it dissolves. If it dissolves, then it's all G.
All right.
Okay, so the next step is once you have your super saturated solution, and you'll know this by when you're stirring it around, you can still see some salt crystals moving. Once you have that, what you're going to do is the evaporation next. So we're going to do some evaporation by pouring this solution into your pot or your pan. So maybe you might want to add a little bit. I'm just going to do a little bit and not the entire cup, so it can evaporate a lot faster. And at the end, those leftover salts are going to be forming a crystal at the end of the pot. Yeah. Fiona, are you ready?
I think I have too much water in my pot to be able to do it. I think
Alright.
this one might just be on you, Covey.
All right, sounds good. I'll take one for the team. Tom, I know that there are other cool things that we can do with crystals and some extensions, right? And something with sugar and rocks. What else can they do?
You know, you're speaking my language, and that language is candy. Yeah, that's right. You can make your own rock candy at home. And again, the smell is just wonderful in this studio. You could make your own rock candy, maybe this stuff that you've seen in candy shops or at the museum, you know, the crystallized candy on a stick. All you need to do is make a super saturated solution of sugar. Wow, what a tongue twister. Let it boil for a little while, and then dip a string in, right? You let it boil just for a little bit, not to allow too much evaporation. Dip a string in, and what actually happens is the crystals will start forming around the string, and, you know, you just save, like, you know, $20 on rock candy, right? You can make your own.
Yum, yum.
I spend at least $20 on rock candy every week.
Yeah, exactly.
All
And
right,
you
Kobe,
can,
what's
yeah.
going on?
So those rock candy is really, really cool too. So like, make sure but you have to wait a little bit longer. You might have to wait like 2 or 3 days for those sugar crystals to form on that string. So you might want to leave it overnight. Maybe put it on your windowsill with a lot of super saturated sugar solution and have the string inside, and that will form that rock crystals. But you can add some food coloring too, and add some like red crystals and blue crystals and all the crystals of the rainbow. So that's a great time. So what's happening right now is that my water is boiling very nicely, and I can see that there are some salt deposits or salt crystals being left down. So I don't know if I can show that, but there are some solid parts. It's just egg.
Oh, is that white sort of splotchy stuff around there? Is that the crystals?
So
All right.
here is some crystals.
Oh
Let's see
wow.
if I can show it a little.
So that's some crystallized salt.
Crystallized salt. Ooh, hot. I'll put it on the table.
Please do not do that at home. The water will be very, very hot. Covey thought that he was wearing his glove. That happens to us all the time here at Couch Potato Lab. Safety first. Not safety the worst.
This is hard to show.
And Covey, if I'm not mistaken, if they don't want to boil it at home, they can just leave their salt super saturated solution out for a few days, and the water will eventually evaporate, and you'll be left with salt crystals, right?
Yeah, so if this is too dangerous, that is a great way that you can do. Another thing that you can, another alternative is to use a microwave. So you can put that glass cup into a microwave, heat it up for a little bit, and then that should evaporate all the water. Maybe not too much water, maybe like I don't know, a quarter cup quarter cup of water, add lots of salt, make it super saturated, and you got it.
Just like Mama used to make.
Tom, hey, look at this. Isn't this so cool? Got some some egg residue and some solid crystals. Hey.
Awesome.
Yeah, it's gonna be great. Ooh, a fun fact about salt. If your like apples are like browning, you can add some salt water to that so it prevents it from browning and making it extra crisp.
Oh yeah.
I did not know that.
Fun fact, hey. Apples are my favorite. Love apples. Sometimes.
Is that your middle name? Apple? Named after the body of water?
Kobe Apple. Cool. Love that.
All right. Excellent. So now we've kind of been, giving little teasers here and there about our good friend Dry Ice, and I think it's finally time that we let that bee out of its hive, hypothetically.
It's time for Dry Ice.
So what I have, where'd it go?
Back here.
To your left,
Hey, it's back
Tom.
there. It's back here. I'm gonna pull out some dry ice, and I think we can do lots of cool experiments that, just to show off how cool phase changes and all that wonderful stuff is. Do you agree?
I agree.
Yep.
Yeah, I'm excited for this next phase change. It's going to be a grand old time, and Fiona has the best. Actually, no, I have the best. But Fiona has one of the best dry ice demos. Fiona, what you gonna do?
All right, so what dry ice does is a phase change called sublimation. So that is when something goes directly from a solid to a gas. It skips being a liquid altogether. It doesn't want to be a liquid. It goes from a solid all the way to a gas. So what we're going to do is we're going to start out. You want to have some sort of, I have a beaker here, and I have it inside this tub because it might get a little messy if we don't have this here. So I'm going to add some green food coloring to the bottom of this. Now I want a pretty fair amount.
Fiona, why did you choose green?
Well, what we're going to be making is a dry ice snake.
A snake?
Yeah, it's going to be pretty cool. You'll see how we make it into a snake in just a second here. But I know, it's like, how do you turn dry ice into a snake?
It goes against all laws of nature, Fiona. Now, I have some dry ice here. If you want to put on your cold glove.
Okay, here we go.
If you want to reach in and early birthday present.
Okay, I got a couple here.
You got a couple?
Yeah. I'm gonna put them down in here for now, just for a second. All right, so the next step to make our snake is I'm gonna just add some, just water, normal water, and fill it up to about halfway. A little more. And now you can really see how green it is. And to capture all of the bubbles and the gases that this dry ice is going to make, I'm going to add some dish soap to the top.
Ooh.
All right. So all of my preparation is complete. Are we ready to see a snake?
Yes.
I'm always ready to see a snake.
Ready.
All right.
A snake? A snake.
You ready?
Okay.
Can I get a countdown?
5,
4,
3,
2,
1.
Lift off.
And there we go.
Wow. It looks
at
like
that.
snake skin.
Yeah, so all the bubbles here are carbon dioxide that's turning into gas, and it's all getting trapped inside the dish soap that's here. So we have made our very own carbon dioxide snake.
Whoa, that is very cool. I don't think we've ever had a live animal here at Couch Potato Labs, so this is a real first, Covey, what do you got going on over there?
All right, so what I'm going to do is I'm going to make a dry ice geyser. So I have this cool bottle right here, and it has pretty much a very small hole right here for the carbon dioxide gas to be released from. What I'm going to do next is I'm going to add some hot water to that dry ice, and it's going to be a cool geyser.
Whoa.
Oh.
Oh yeah!
Whoa.
Ta-da! Woo!
You know, it's like, you know, like a rock concert. You know, when you're walking out on stage, Covey, because I know that you're a pretty big rock star, right? So you're probably used to seeing this all the time when you walk out on stage, hey?
Yeah, or like when you go to the like carnivals.
Oh,
and they
yeah.
have those like cool ice creams that like have dry ice, and it's like, oh.
Oh yeah, that's
You know?
true. That's true.
Yeah, this is my secret power. This is how you can trick your friends and say, wow, look at me go. I can make clouds appear.
You know, we always appreciate a good weather prank. Now, I also have a little demo. I'm not just your charming host. I'm also a bit of a scientist myself. So, what I have here as well is some. I just have a tub of water. You know, nothing special. I'm gonna add a bit of dish soap. Again, nothing special about dish soap. Just gonna give it a few drops. And like Fiona, I'm also going to add some dry ice, but also I'm going to be observing the properties of the bubbles a bit closer. So I'm just going to pour some in. Let's get it going. You know, let's get it.
Ooh.
All right. So hopefully, yeah. So we'll see that it starts building up just like the snake did. Now let's see if I can get this right. So now I have some bubbles here, and as you can see. I'm going to try to pop a couple. Look at that. They're all smoky. But it's not actually smoke. It's that carbon dioxide. Here, I'll grab a bit more. I'll grab a bit more because it's you know. Oh, I'm going to. There we go. Just get rid of it real quick. Just because I added too much dry ice, folks.
What does it feel like, Tom?
It's actually not cold at all. It's quite warm, actually. So. We talked about why dry ice is so cold. Is frozen solid carbon dioxide that is taking its pellet form. But once it hits something that is not negative 78.5 degrees Celsius, it starts evaporating into carbon dioxide gas. And that's what you're seeing right here, is that carbon dioxide gas. Wow, this is... I'm going to be at this for a while, folks.
It just never ends.
It's just never going to end. I'm probably going to be on tomorrow's episode still just doing this little clappy thing, you know? People are going to ask, what's going on? And we'll say, watch the previous episode.
Tom, wouldn't it be so cool if our beakers in the back all smoked as well with carbon dioxide gas?
That would be really cool, Covey.
Nice.
Do you think we should do it?
Why not? Let's do
all
a
right.
couple beakers.
I'll move just so we can keep social distancing.
Wow.
Ooh. We look like we're doing some crazy experiments now.
Look at that.
Woo! What a grand old time.
All right. You know, we're going to have to send this off to our lab for analyzing. Just going to get rid of the old thing. Thank you. Thank you, thank you. Covey, you're doing great over there.
I'm doing great. Looks good.
You know, we have these really fancy chemicals that we've been working on. And, you know, they've just been sitting there the entire time. And I say, no way. Those chemicals need to be boogieing like they are now. So thanks for doing that, Covey. That was dry ice. It's pretty cool, hey?
Mm-hmm.
Yeah, it's very
pretty cool.
So far we covered 5 phase changes.
Right, 5, yeah.
And there are 6 phase changes. So the next phase change that we're going to talk about is deposition. And what deposition is a phase change from gas to solid.
Gas to solid.
Gas to solid. Tom, can you think of any deposition examples?
You know, these are the questions that keep me up at night. Oh, I have one.
Ooh, you
I
do.
do have one. In fact, I think the crew also has a GIF loaded up. Let's talk about frost formation.
Yes.
Right?
So here, ooh,
Beautiful.
this GIF lol, is hoarfrost, and it's showing the example of deposition. So again, so what's happening here is that the water vapor is very moist along with the air around it. So when it's a really, really low temperature, it freezes into those crystallines, and it's usually on like your benches, not benches, your fences and some vegetation.
And you know, it could be some benches if they're made out of metal, right?
Oh yes, exactly.
You know,
Yeah.
frost is everywhere, and that's deposition. That's something that we don't really think about because just the concept of going from a gas to a solid. If we remember from our previous episodes, gas molecules are crazy. You know, they're bouncing everywhere. They're going every which way, just like my hands. And then you got liquid, and they're a little, they're a little more tame, but they're still wild. But then we have solids, which are just nice uniform molecules. So to go from that crazy molecule arrangement to a nice solid blows my mind. So, yeah, I think we've covered all 6 of them.
All 6.
Yeah, I believe so.
Huh.
Yeah.
Well, that can only mean one thing. We got to test our knowledge on our science showdown.
Dun, dun.
Whoa.
That's right. It is time for Science Showdown, the part of the show where we test our experts' knowledge on the things that we learned today. Now, it's a very special episode because it's going to be all about reversible and irreversible reactions, like we talked about before with the egg, that wonderful, wonderful egg that I keep smelling. It's great, folks. So I'm going to just give an example of something in nature, and you're going to have to tell me whether it is a reversible or irreversible reaction. Does that make sense?
Yes, I am ready.
All right, do like a virtual handshake just for good sportsmanship. There you go. Looks great. Okay, your first one is burning wood. Is it reversible or irreversible? 3, 2, 1.
Ah,
Kobe.
it's irreversible.
Irreversible is
Yes.
correct. Correct. It is correct. Yeah. Once you burn a piece of wood, it turns into ash, which is, you can't make a tree from ash. Is what I always say. Our next one is, well, we already did this. What is cooking? I'll give you 3 seconds. 3, 2, 1.
I got it.
Fiona.
Ah,
It is irreversible, just like my lovely egg that I hope not to eat.
Exactly.
Oh.
That's right. I'm not just a host. I'm also a comedian. That's right. Cooking anything, we add that temperature. The proteins get denatured, which just means that they get broken out of their regular shape. So that's what happens. Unfortunately, you can't uncook an egg, is what I always say.
it's always scrambled.
It's always scrambled. All right, this next one's a bit trickier. The rusting of iron. 3, 2, 1. I'm gonna. The slow-mo camera that I'm just reviewing right now says that Fiona.
All right. I'm going to be honest. I don't really know the answer of this, but I have a 50-50 chance of getting it right.
Ooh.
I'm going to say it's reversible.
Folks at home, that is not right at all.
Dun, dun,
It is
dun,
an irreversible reaction. In fact, it is called oxidation. We've talked about oxidation a couple times on our show, haven't we? Yeah, that's where oxygen molecules sort of, to put it violently, they attack the metal, and so that causes a color change, and it creates a new alloy. It creates a new chemical composition for something like an iron nail. So the best way to deal with a rusting nail is to just shave off the rusty part, and you got a brand new nail. But good guess, Fiona. Good guess.
Thanks.
One step closer to that egg.
Oh, boy.
All right. Next one is phase changes. 3, 2, 1. Kobe.
Reversible.
That is right. They are reversible. So just like how you can melt, I was going to say melt an egg, but you can melt some ice. You can also freeze an ice to make it, to freeze water to turn it into ice. That's right. That's my name right there. Absolutely. I'm still Tom. Okay. So next one is vinegar and baking soda. 3, 2, 1. Oh, that's Fiona.
I think it is irreversible.
Irreversible is correct. It breaks down into several different chemicals that I can't remember off the top of my head. I know one of them's acetate and the other one is water. Great job. So I think you're about 2 for 2 now.
Really?
I think.
Oh.
I think. Should we do one more as a tiebreaker?
Yes.
Okay.
All right. All right. I gotta think of something. I gotta think of something devious.
Oh boy.
Yes.
All right. How about making cheese? 3, 2, 1. Kobe.
Making cheese. Making cheese? Irreversible.
Sorry, Fiona. That's correct. It is irreversible. You know, just look at a piece of cheese. It's solid. No matter how much stuff you do to it, it's never going to go back to being milk. It goes through, it goes through a process of denaturation, like we were talking about, where bacteria is transforming it into this product that we know as curds, and then it solidifies, and that's cheese. And that was Science Showdown.
Yeah.
You know, I could talk about cheese all day, but tight sketch. So unfortunately, Fiona, you did lose today's
Oh no.
Science Showdown. Kobe, you were victorious.
That means she gets to eat the eggs.
And you know what? You know, I don't want to watch her eat an egg. I don't want to watch her eat an egg. So you know what? I think I'm going to make her have some of that ice cream once the show is done.
Oh,
Yeah.
wow. Okay.
Yeah.
All right. I'm fine with that. If we can share that ice cream, that would be a fan-dandy thing to do.
You know, it's still a punishment for me because I'm lactose intolerant.
Oh, wow. Double whammy.
So, still lost.
And that was Science Showdown. Hey,
Tom, I have something to confess.
Kobe.
So the thing is, we can actually reverse Russ.
No way.
Yeah, so that means Fiona gets another point, and we're tied.
Oh boy.
But because we're tied, we're gonna share ice cream anyway, so we all win. And I think the ice cream is lactose free. Yeah.
Yes.
Yes. We got it. We're fine.
Excellent. I'm glad that we cleared the smoke from the room here. It is time now for our STEM Spotlight, the portion of the show where we like to highlight someone in the field that relates to our episode. So, ladies and gentlemen, STEM Spotlight.
Today's STEM Spotlight is Dr. Katja Frederick. Dr. Katja Frederick is an assistant professor and associate chair in the Department of Atmospheric and Oceanic Science at the University of Colorado. Her research direction is in the investigation of kinematic and microphysical processes relevant for cloud formation and enhancement of precipitation, with a special focus on improving quantitative precipitation estimation and forecasting heavy precipitation, thunderstorms, and windstorms. Sounds like that's pretty important here in Saskatchewan. Great work, Dr. Katja.
And that was Dr. Katja Friedrich. It's now time for a very cool part of our show. I think it's my personal favorite just because I love interacting with the audience so much. It's time for Ask Our Scientist. All right. I'm not actually sure if there is music. This is the part of the show where we get to your questions that we weren't able to during the program. So let's start off with, let's just get it out of the way. Kobe, we have more guesses for your middle name.
What are the guesses?
We have Ocean, Brook, Creek, Slough.
Slough? Oh,
Covey, Slough.
Covey Slough.
Kobe, what is your middle name?
My middle name is Lake, and I believe someone mentioned it already, so nicely done. It's Covey Lake. That's my middle name.
Excellent.
All right, what other questions do we have today, Tom?
Honestly, it's another one for Kobe. It's from our good pal Eli. They asked, is Kobe really 35 plus years old? Kobe?
No, I'm not 35 years old. I'm actually 34 years old.
Mm-hmm.
Yeah.
Glad that we cleared that up.
It's a struggle.
It's a struggle. All right, our next one is from an unknown viewer. They asked to remain anonymous. Ooh, spooky. Why is dry ice cold? Fiona, do you know the answer to that?
Yeah, so dry ice is cold because in order to get it into a solid form, scientists have to cool it down to negative 70, what is it, 79?
Yeah, about
S-
79.
about 79, yeah.
Negative
Yeah,
79.
negative 79 degrees Celsius. So since it has to be that cold to be solid, clearly if you touch something that's negative 79 degrees Celsius, it is going to feel pretty cold.
Yeah, real cold. Some would say ice cold. Dry ice cold.
But
Hey. We have a lot of fun here. You know, I feel like we always get a couple questions about plasma. You know, so here's a great one. Are there phase changes with plasma?
Yes, there
Kobe, you
is,
got it?
Tom. There is a phase change with plasma. It can go to gas. So what happens, the two processes it goes through is ionization and recombination, and that deals with either gaining or losing electrons in their atoms. Yeah, so electrons is little tiny particles that have a negative charge, and we'll probably cover that in another episode.
Nice, nice. So really, there's about 8 phase changes, 2 specifically for plasma.
I guess so, yeah.
Very
we'll add it
cool.
on.
Okay, I think we have time for one more. What phase change happens when you sweat? When you work out? When you pump that iron? What happens, Fiona?
All right, so when you sweat, you get little beads of sweat on your skin, and it evaporates.
Evaporates.
Yeah, so the heat from your body working out so hard causes the sweat to evaporate off your skin, and that makes you cool down a little. So that's what happens. You might also feel it when you get out of a nice hot shower, and then you step out, and then you start to get a little cold, and you get all those goosebumps. That's from the water evaporating from your skin. So yeah, that is what happens when you sweat.
Very cool. And actually, there's some evolutionary theories that sweating provides an advantage for humans over other animals because we're able to run for longer periods of time because our body is cooling us down, whereas other animals, they don't have the ability to sweat, and therefore they need to physically stop, and that makes it much easier to hunt them.
Oh.
Yeah, so next time you're all out in the sun, it's a really hot day, just think, wow, I'm happy I'm sweaty because I can go hunting later. I don't know. This has been Ask Our Scientists.
My middle name is Lake. It's Lake. That's my middle name.
All
Yeah.
right, all right.
All right, Tom,
yeah.
do you know it now?
Yeah, we said everybody wants to know your middle name. There you go.
Yeah, it's Lake.
It's Lake. So this has been today's show. We talked about phase changes. We talked about clouds. We talked about the weather. We talked about cycling. What a crazy episode, right?
Yeah.
Yeah.
So you could find us here again tomorrow. We're going to be talking about something really cool. I'm not quite sure what we're talking about, but it's going to be pretty cool. Kobe.
It's in your brain.
It's in your brain.
It's in my brain? No, it's about your brain. It's how you think.
Oh, my name is Tom.
And my name's Kobe. And Fiona.
Yeah.
I have 2 names.
And now some words from our supporters that made it all possible. Bye, everybody.